Welcome to today's Explainer. May 20th might seem like just another ordinary day on the calendar, right? But following the structure outlined in our source document, ENGV, we're actually going to see why it's without a doubt one of the greatest dates in the entire history of mathematics. Today, we're looking at exactly why that is and how a few brilliant minds totally changed the world we live in.
So here's the crazy part. On this single date, across completely different centuries and countries, multiple innovators made massive discoveries that we literally use every single day. We're going to journey through the years 1677, 1782, 1908, and 1951. Let's just go ahead and meet these innovators one by one.
Okay, let's dive into this. Have you ever actually stopped to wonder how your favorite video games or apps keep track of a score that's just constantly changing? Or say how your character's health bar knows exactly when to drop during a super intense boss battle?
Well, believe it or not, the answer goes all the way back to May 20th, 1677, and a guy named John Kersey.
So, John Kersey was this incredible pioneer who championed a really simple but absolutely powerful idea in algebra. He realized, hey, we could just use simple letters, like A, B, and C, to represent unknown numbers, and then he treated those unknowns just like real numbers until the equation was actually solved. Now, this might seem like basic everyday math to us now, but back then, it was revolutionary. By treating a letter as a stand-in for a number we just don't know yet, he basically built the foundational logic for all modern coding. It's exactly how our computer programs store changing variables today, like those video game scores we just talked about.
And this brilliantly illustrates one huge, powerful truth. Every single line of code in our apps relies on the magic of unknowns.
Okay, so we're still on May 20th, but let's jump over 100 years forward. The year is now 1782.
Think about this for a second. How does your smartphone map instantly calculate the exact distance and motion needed to guide you home? How does it so seamlessly track where you are and where you're going, even when you're flying down the highway in a car?
The answer actually takes us to May 20th, 1782, which is the date we lost a highly eccentric but absolutely brilliant mathematician named William Emerson. Emerson basically spent his entire life obsessively exploring the mechanics of the physical world, and he did this in two major steps. First, he worked to map the geometry of the world using trigonometry. And then second, he relentlessly tracked continuous movement and forces using the calculus of what was called fluxions back then. It's wild to think about, but all of Emerson's intense work on navigation, like tracking ships across the ocean and calculating continuous motion way back in the 1700s, is the direct ancestor of the technology powering our digital maps today. It's just mind-blowing. The math of moving ships in the 1700s is the exact same math guiding our GPS today. Who would have thought that historical ocean navigation would literally birth the tech we all carry in our pockets? Moving right along, same date, but we're jumping forward more than 100 years again. We're heading into the 20th century now. The year is 1908, and here comes a really massive idea. How do we actually control the massive flows of electricity that power our modern cities? And honestly, even more mind-blowingly, how do those exact same invisible flows of energy exist way out there in the extreme environments of the stars?
Well, the answer goes back to May 20th, 1908, which happens to be the birth date of Alfvén.
Alfvén was incredible. He pioneered an entirely new field, plasma physics and electrical engineering. He actually discovered exactly how magnetic fields interact with electrically conducting fluids. So the crucial point is that his Nobel Prize-winning work helps us understand both the cosmos and how to manage the electricity we use every single day right here on Earth. He really showed us that space physics isn't just for astronomers staring through telescopes. It actively helps us generate power right here at home.
It's just awesome to think about. The invisible forces lighting up the cosmos are the same ones we study to power our future. It literally connects the vastness of deep space right to the power grids sitting in our homes. One date, right? So many different stories. Let's make one final jump. We are still on May 20th, but now we're arriving in the year 1951. Here's a fun question for you. Can you do experiments in math without test tubes or microscopes? We always picture a laboratory as this room full of bubbling chemicals and glass beakers, right? But what does a math lab actually look like?
Well, this brings us to Jonathan Borwein, born on May 20th, 1951.
Borwein really championed a totally brand new way of looking at numbers. He literally invented the field of experimental mathematics. So instead of just using a pen and paper like traditional mathematicians, he used computers as a literal laboratory. We're talking running billions of calculations to test ideas and find these totally invisible patterns. Borwein realized that, hey, computers aren't going to replace human mathematicians. Instead, they're going to act as an incredible tool to help our brains test complex theories basically instantly.
Now, what's really interesting about this slide is the core idea he pushed forward. Computers gave us a laboratory to experiment inside the universe of numbers.
So, let's take a look at this full journey one last time, from 1677 all the way to 1951. 4 incredibly different minds spanning centuries, all united by this single date in history.
Every single person we met today in this explainer, whether they were from different centuries or different countries, they all asked the exact same fundamental question. What is the pattern hiding inside the chaos? And because they asked that question, our world today has coding apps, GPS, and reliable electricity. So as you go about your day, look closely at the world around you and ask yourself, what pattern